Let's review Chapter 4 on decimals. Yeah, we'll look at the main topics. Those are rounding, adding, subtracting, multiplying, and dividing. Also scientific notation, and we'll look at percents from this chapter. And yeah, if you want more details, you can go into the notes. Okay, how about a rounding problem? So example 1, round this decimal to the nearest hundredth. So remember the places. So this 2 represents ones. This is 7 tens, 4 tenths, 3 hundredths, 6 thousandths. But here we want to round to the nearest hundredth. So this is the hundredths. So that's the round off place. When you're rounding it, you need to check the next digit. If it's between 0 and 4, then we keep the 3. But here it's between 5 and 9, so this 6 is between 5 and 9, so that means we have to move that 3 up to a 4. Okay, so this decimal, it's closer to 72.44 than 72.43. Okay, so that 3 goes up to a 4, and then make all the digits to the right of that 0, and these are insignificant, so you can just ignore them. Alright, so that's the answer, 72.44. Okay, rounding, so yeah, just find the round off place first, and then check the next digit. How about subtraction? Okay, so for addition and subtraction of decimals, the main thing to do is to line up the decimal point. So 17.4 and 5.63. So it's helpful to line these up to, you can add an extra 0, an insignificant 0 to the 17.4. Alright, and the decimals are lined up, including the decimal point of the answer, and that's going to line up in the same line. And now you can just pretend they're whole numbers. Okay, so 3 from 0 doesn't work. I'll borrow a 10, or borrow, yeah, pretend that's 4 tens, so borrow one of those 10s. 3 from 10 is 7. 6 from 3 doesn't work either. Borrow from this column, so we get a 13. 6 from 13 is 7. 5 from 6 is 1. And 0 from 1 is 1. So the answer, again, the decimal point goes here, so that's 11.77. And just double checking this makes sense. Yeah, if it was, say, 17 minus 5, that would be 12. And this is close to 12. All right, so for adding and subtracting decimals, line up the decimal points. But multiplying decimals is different. So here you're not lining anything up. Example 3, multiply 0.08 by 0.023. And the way to do it is to first add up the places. Okay, so this first decimal has 2 digits to the right of the decimal point, so 2 places. This one has 3 places, and 2 plus 3 is 5, so we want to give the answer 5 places. Then pretend these are whole numbers. So 8 times 23, that's 184. So you can write it as a whole number. It's 184 with the decimal point here. And then give it 5 places. So move the decimal point to here. Okay, so the answer has 5 places. Here we added some insignificant zeros to the left. So 0.00184. That's the answer. All right, so yes or no, you're not lining up decimal points for this. You're counting places. 2 plus 3 is 5, so the answer has 5 places. Okay, and the reason it works, yeah, you could think of this as 8 over 100. You could think of this as 23 over 1,000. So if you multiply those two fractions, that's going to be 184 over 100 times 1,000. That's 10,000, or sorry, 100,000. So 100,000, that's 5 places. Okay, how about division, the last operation? Example 4, divide 1.918 by 0.7. Okay, so if you're dividing by a decimal, the idea is the first step is to make this a whole number. And yeah, so think of it as this decimal divided by this decimal. We want to make this a whole number. We want to move the decimal point 1 place to the right. So that's the same as multiplying by 10. So multiply the top and bottom by 10. So we're just moving the decimal point for both numbers to the right. So an equivalent question is 19.18 divided by 7. And that's what we'll do. So we'll do this long division. And the point of that first step is, yeah, if you're dividing by a whole number, then the decimal points line up when you're doing the division. Okay. So the decimal point in the answer, it's just going to go above that decimal point in the 19.18. All right, 7 into 1 doesn't go, but 7 into 19 goes twice. Put the 2 over the 9. Subtract 14, bring down the 1. 7 into 51 goes 7 times. Put the 7 over the 1. Subtract. Bring down the 8. So we're getting 2.74. Alright, so it's people not getting this quite right in the homeworks. So if you're dividing by a whole number, you can just go straight to this step. But if you're dividing by a decimal that's not a whole number, and move the decimal point in the number you're dividing by to make it a whole number. And if you move it so many places here, you have to move it the same number of places for the other number. And so once you're dividing by a whole number, then you can line up the decimal points like this in the long division. All right, and yet does this answer make sense? So something close to 2 divided by something close to 1. 2 divided by 1 would be 2. Yeah, this bottom number, it's a bit smaller than 1, so it's going to make this bigger than 2. So the answer roughly makes sense. Yeah, 19 divided by 7, yeah, that's yeah, 21 divided by 7 would be 3, so maybe that makes more sense. All right, example 5, just one example of scientific notation. Convert this decimal to scientific notation. Alright, so what that means is we want to write it as a number that's between 1 and 10 times the power of 10. Okay, so multiplying by powers of 10 or dividing, that means moving the decimal point. Okay, so we want to make this between 1 and 10, so move the decimal point to between the 3 and the 8. Okay, so we're moving it 4 places to get 3.82. Okay, so we made it 10,000 times bigger. So to keep it the same, divide by 10,000, and that's the same as multiplying by 1 over 10,000, that's 10 to the negative 4. Okay, so moving 4 places to the right gives 10 to the negative 4. If we had to move it 4 places to the left, it would be 10 to the 4. Just remember, very small numbers have negative exponents. Very big numbers would have positive exponents. Okay, and the last thing we looked at in chapter 4 was percents. In this example, convert 6% to a decimal and a fraction. Okay, well, certainly any percent as a fraction, it means it's that number divided by 100. And so 6 over 100. And we can simplify this fraction, cancel 2's, that's 3 over 50. So 6% as a simplified fraction is 3 over 50. And as a decimal, it's 0.06. All right, so converting a percent to a number, you can write it as a decimal or a fraction. And here's an application of percents. Example 7. In a sale, the price of a TV that usually sells for $300 is reduced by 20%. Find the sale price. And so first we need to find 20% of 300. And so what was the reduction? So convert that 20% to a number. Here I've used a fraction. Of means we're multiplying. And 300, they're multiplying fractions. So 20 over 100 times 300 over 1. Multiply straight across, that's 6,000 over 100, which is just 60. All right, so the price went down by $60, so the sale price is $240. Yeah, multiplying these two fractions, yeah, we could have pre-cancelled here, so cancel this 100 with 100 out of the 300, so it's 20 times 3 over 1 times 1. Okay, and when you're getting a percent of a number, the operation you need is multiplication, so don't forget that. All right, so next chapter, chapter 5, we looked at ratios. So ratios, you're just comparing two numbers, just like a fraction. So 3 to 5 is a ratio. You can write it with a colon, 3:5. And as a fraction, the first number goes on top, the second number on the bottom. Also, a proportion says that two ratios are equal. All right, so something like this, 3/5 equals 6/10. So that's a true proportion. And one way to check that a proportion is true is to look at the cross products. So the first cross product here is 3 times 10, that's 30. The second cross product is 5 times 6, that's also 30. And so because those two cross products are equal, that tells you that it's a true proportion, that 3/5 is equal to 6/10. And we also look at rates. So here, a rate is comparing two different types of things, so two numbers but measuring different types of things, like dollars to hours for pay, for example. So your hourly rate would be the amount you're paid per hour. Example 1, simplify these ratios. So part A, we have the ratio of 15 to 60. All right, so to simplify this just means write it as a fraction and then find any common factors and cancel them. So in fact, they have a 15 in common. So if you cancel 15, so you get 1 over 4. So the simplified version of this ratio is 1 to 4. So in this first ratio, the second number is 4 times as big as the first number. Okay, how about part B? Let's compare these two mixed numbers. Alright, so the operation is division, so think of this as 8 1/3 divided by 7 1/2. How do you divide mixed numbers? Well, convert them to improper fractions. So here we have 3 times 8 plus 1, that's 25 over 3. Here we have 2 times 7 plus 1, that's 15 over 2. Alright, keep, change, flip. So that's equal to 25 over 3 times 2 over 15. Multiply straight across, 50 over 45. Cancel 5s, and we get 10 over 9. So simplifying this whole thing to a fraction, we get 10 over 9, and back is a ratio that's 10 to 9. Alright, so comparing the original two numbers, and we can see the first number is bigger than the second number, and a clearer way to see their relative sizes is to say it's this ratio, it's the same as 10 to 9. Alright, so just remember you're dividing. How about a proportion? So example 2, we have this is supposed to be a true proportion, and we're missing one of the 4 numbers. So 15 over 40 is equal to 12 over what number? So what do we need here for x to get two equivalent fractions? Alright, so when you're solving a proportion, there are 3 good steps. Step A is to simplify, if you can, the fraction on one side, so the one that doesn't have a letter. Does this simplify? Yeah, we can cancel 3's, and so 15 divided by 3, so we cancel 5's. 15 divided by 5 is 3. 40 divided by 5 is 8. Okay, so we can replace this side with 3/8. 3/8 equals 12 over x. Step B, set the cross products equal. So 3 times x. That's the first cross product. 8 times 12. That's the other cross product. So 3x is equal to 96. Okay, so step B is setting the cross products equal. Step C, the last step, we're looking for 1x, so divide both sides of this equation by 3. So if 3 times x is 96, divide both sides by 3, so 1x has to be 32. Alright, so the number we were looking for was 32. And yeah, you can see that makes sense if you cancel 4's, so 12 over 32 if you reduce that fraction, yeah, you also get 3/8. All right, so the rest of the problems in this chapter involve solving proportions, so different applications. All right, so you've got a proportion, one of the numbers is missing, then use these 3 steps to find that missing number. Okay, so the first application is to percent problems. And we're using this idea. If you see A is P% of B, or P% of B is A, then you can write that as this proportion, so it means the same thing. Yeah, you can see this is A equals P over 100 times B, and divide both sides by B, and you get this. Example 3. 3 is 11% of what number? And give your answer as a mixed number. Okay, so we're comparing these two. So the A is 3, P is 11, and we're looking for the B. So B is the base. It's so think of A as a part of the base. Okay, so our formula says we're dealing with this proportion, so 3 over B equals 11 over 100. And now we can solve this just like last time. Step A, look to simplify the fraction. Yeah, this one doesn't simplify. Step B, set the cross products equal. So 3 times 100 is equal to B times 11, or 11 times B. And so 11B is equal to 300. Step C, divide both sides by 11. So 1B is equal to 300 divided by 11. And then just to write that as a mixed number, so 11 goes into 300 27 times, remainder 3. So as a mixed number, it's 27 and 3/11. And so going back to answer the question, yeah, so 3 is 11% of what number? Of this number, 27 and 3/11. All right, so those are percent problems. And they look like this. Problems with rates. They also turn into proportions that we need to solve. Example 4. If a factory produces 45 cars in 6 days, how many are produced in 10 days? Okay, so we're comparing cars produced by the number of days they're produced in. So the first part of the sentence, we've got 45 cars produced in 6 days. How many are produced in 10 days. Okay, so we're comparing cars to days. So for the second rate, do the same thing, compare cars to days. We're looking for the number of cars, that's X, and we want to know how many produced in 10 days. Okay, so the rate we're talking about here is the number of cars the factory is producing per day. And we're assuming that it's like a constant rate of production, so these should be equal. And the basic proportion here is 45 over 6 is equal to X over 10. Okay, so once you have this figured out, then it just goes back to another proportion to solve. Yeah, we can simplify this to 15 over 2, canceling 3's. So 15 over 2 equals X over 10. Set the cross products equal. And so 150 is equal to 2X. And divide both sides by 2 to get 1X. And writing out the answer, so that the factory makes 75 cars in 10 days. Okay, 75 cars. And yeah, you can see that makes sense. So 45 cars in 6 days. So the factory would make 90 cars in 12 days. And a bit less than that, 75 in 10 days. Yep. And the last topic in this chapter, similar triangles. Okay, so two triangles are similar if they're the same shape, but one could be smaller, one could be bigger. Really, they have the same angles. But if you have two similar triangles, then ratios of the lengths of corresponding sides are always equal. Example 5, if these two triangles are similar, find the missing side X. Okay, yeah, so these questions are a bit confusing. Your first job is to, since these two triangles have the same shape, you want to find what are the corresponding sides. Okay, well this side here, this 3 in this triangle corresponds to this side length 4 here. Okay, so these are two corresponding sides, so we can make the ratio 3 to 4. We can also see these two sides correspond, so we get another ratio 5 to X. And these two sides correspond, so we get 9 to whatever this length would be. We're not given that number. Alright, so we're just going to use these first two ratios where we have two numbers and a number and the X we're looking for. Okay, so the ratios of corresponding sides we're using are 3 over 4 is equal to 5 over X. That's because the 3 corresponds to the 4, and the 5 corresponds to the x. And we're using the top numbers come from the first triangle, the bottom numbers are coming from the second triangle. So that's a good way to do it, to keep them straight. Alright, then solve this. 3 times x is equal to 20. Divide both sides by 3, so x is 20 over 3, or 6 2/3. And that's the answer. X is equal to 6 2/3. And yeah, so you can see that this second triangle, it's just slightly bigger than the first one. So the 3 goes up to 4, and the 5 goes up to not 6, but 6 2/3. Okay, so yeah, you can't add, it's really you're multiplying. Alright, so similar triangles. Another application of these proportions.